All right, we're going to go ahead and continue with the Honors Pre-Calculus B semester exam review, and we left off with problem number 5, so that's what we're going to start with today. And again, you can follow along in your review packet. Okay, so just like any other problem, I'm going to go ahead and factor anything that I can to reveal any information that I could possibly use. So if you look at the top here, this factors to the following. And so right away we can write down some information such as the vertical asymptote, which is at x equals 6. That's when the denominator is equal to 0. The horizontal asymptote, which this problem is very interesting in the sense that it does not have a vertical asymptote because the degree of the top is bigger than the degree of the bottom. Okay, but it does have what's called an oblique, or some would call it a slant asymptote. Okay, so we're going to have exactly that, a slanted asymptote. And to find that, if you don't remember how to find that, we have to use polynomial long division. So write everything in standard form. Make sure there's no gaps that are missing in the sense that it should go x squared, x, no x. And so we're going to do division here. So x goes into x squared x times. In other words, x into x squared is x times, because x times x is x squared. So I write that here. Now I do negative 6 times x, which is negative 6x. And I'm subtracting this entire thing. Notice how I put in parentheses. This will go away. Then I have a negative, negative. So I have negative 8x plus 6x, which is negative 2x. Bring down the 7 and do the whole process one more time. So x goes into negative 2x, negative 2 times. And now negative 6 times negative 2 is positive 12. Subtract everything. These cancel. Then I have 7 minus positive 12, which is negative 5. And actually, the only part that I care about is the result up here. The remainder actually is not a part of the slant asymptote. So there's my slant asymptote. Now I can find some other information, such as the x-intercept, or in this case, x-intercepts. So if I set the numerator equal to 0, I get 1, 0, as well as 7, 0. So this has two x-intercepts, again, coming from setting this and this equal to 0 and solving for x. The y-intercept, if I plug in 0, I will get negative 7 6. Okay, so now we can go ahead and start to graph this. I'm actually going to graph it on the next page. So let's continue on the next page. So let's use some information that we have. So we have the vertical asymptote was at x equals 6. We did not have a horizontal asymptote, but we had a slant asymptote of y equals x minus 2. So you graph that line. So y equals x minus 2 has a y-intercept there at negative 2 and a slope of 1. So from here, I'm going to go up 1 over 1, up 1 over 1, and so on. So it should look roughly like so. Okay. Now we also have a x-intercept at, let me go back. We had an x-intercept at 1, 0 as well as 7, 0. So we have one right here, and we have one right here. And that actually tells me what this is going to look like. We also have a y-intercept at negative 7, 6, which is a little bit bigger than negative 1, a little more negative than negative 1. So this one is going to look like this. So it's kind of very broad, and then it would keep going up there. So you can see how this would turn out because of the slant asymptote. It's got kind of a slant to it. Lastly, we can say the domain and range, which was the last thing they wanted. So the domain here is all real numbers, except x can't be 6 because of the vertical asymptote, and the range here is all real numbers because it actually goes all the way down and all the way up and covers every number in between. Okay, let's continue with number 5. Or excuse me, number 6. We just did number 5. And by the way, just going back to the last one, there will always be a slant asymptote if the degree of the top is exactly 1 more than the degree of the bottom, which was the case there. So here's number 6. Okay, so finally we're getting past the graphing here. So this one is simply asking which of the following is the equation of the horizontal asymptote of the graph of the function, and then they give you this function, and you can see the degree of the top is exactly the degree of the bottom, so I take the ratio of the leading coefficient of the top divided by the leading coefficient of the bottom. So my answer would be y equals, the horizontal asymptote is y equals 4 over 1, which is 4, and that is option D. So that would be my answer here. Okay, so just a quick multiple choice problem. Let's go on to number 7. Number 7 is 7 and 8 are both rational equations. So we have rational functions, but we're actually trying to find out what x is. Okay, so first of all, I'm going to rewrite this a little bit. I'm going to factor everything in the bottom. So that's already factored. And what I meant by that is the bottom of the 12 is actually a difference of perfect squares. So that's going to reveal some information about the least common denominator, or LCD, that I need. So here you can see the LCD is going to be exactly x minus 1, x plus 1. That's what's in everything, except for the 2. So this 2 I'm going to have to multiply by x minus 1 and x plus 1, but the LCD is exactly that. So I will multiply this side by x minus 1, x plus 1, as well as this side by the same thing. Let's squeeze it in here. So here you can see these will cancel, so I'll be left with 3x, x plus 1 equals, here both of these show up here and here, so I'm just left with the 12. And lastly, the 2 has nothing here, so I have to multiply both x minus 1, x plus 1 times the 2. And the rest of this is just kind of some simple algebra. So here I distribute the 3x. Here I'm actually going to hold off on the 2 and multiply out x minus 1, x plus 1, which you would get this. Not surprising, because we factored it up top. Distribute the 2. If I move everything over to one side, I like to keep my x squareds positive, so I'm going to do that. I have x squared plus 3x equals 12 minus 2, which is 10. So there, if you didn't catch that, I did 12 minus 2 to get 10. So then, let's bring this up here. I'm going to move everything over. Because I have a quadratic, I need to get it equal to 0 to factor and solve. So this factors to x minus 2, x plus 5. By the zero product property, I set each one of these equal to 0 and solve. And so here I have two answers. Okay, so those are my my two answers here. None of them are extraneous because if I go back and plug them into the original problem up here, I don't get division by 0, so that's good. All right, let's continue with problem number 8. And just to save some time, I'm going to go ahead and factor the bottom of the problem that says x squared minus 6x plus 8. That factors to the following. Okay, so my LCD is going to be x minus 2, x minus 4. And so I'm going to multiply that on both sides. Just to save some time, I'm going to go ahead and just write the result. So here I'd be left with, if I multiplied this by this, the x minus 2's would cancel. I'd be left with x times x minus 4. If I multiplied this with this, the x minus 4's would cancel. I'd be left with 3x times x minus 2. And if I multiplied this with all of this, both of these would cancel, so I'd just be left with the top here. So we'll save some time with that. Okay, go ahead and do some algebra here. Go ahead and combine terms. So I'm going to subtract 32. You can already see you have a quadratic, so I'm going to subtract 32 over here and add 2x over here. So I have x squared, then I have negative 4x minus 6x is negative 10x, negative 10x plus 2x is negative 8x. And then I'm left with a minus 32. And I actually made one slight error here. I forgot to add the x squared with the 3x squared. So this should actually be 4x squared. And that all equals 0. I'm going to go ahead and factor out the 4 just to make my life a little easier. Okay, you can divide the 4 out. So this is still 0. So I have x squared minus 2x minus 8 equals 0. Factor it to solve. Okay, and you can actually see that this one is extraneous, because if you go back and plug in 4, you'd get division by 0 here. Negative 2 is okay though. So this would be my answer, and I would just note that 4 is extraneous. Okay, so there are problems 5 through 8, and we'll continue with the next session.